So in section 4.4, we have a binomial random variable. Okay. So in this section, we'll focus ourselves on the experiment that has outcomes too. Okay. So we'll be talking about the experiment which has an outcome or a response too. Okay. For example, like if we toss a coin, how many outcomes we have? We're going to have two outcomes, right? So head or tail. So similarly, if you are asked whether will you pass this course or not, so how many responses we get? See, two, yes or no. Okay, so we will be focusing on the experiment that has two possible outcomes. Okay, and this binomial random variable has 5 different characteristics. The very first one is the experiment consists of n identical trials. For example, if I toss a coin for 5 times, okay, I have the experiment in my experiment I'm tossing coin for 5 times. Okay, now so I have a 5 different trial of tossing a coin. Okay, now are all those 5 experiment or the trial is similar or not? If you toss a coin 5 times, will that trial be similar to each other or not? They are identical, right? So we are tossing a coin 5 times, so it's the same experiment. They are similar, right? So your experiment has to consist of any number of identical trials. The trials has to be similar, has to be same. Okay, if I ask each of you, like, will you pass this course or not, for each of you, so we have like 18 students, and if I ask the same question for 18 of you, then I have the similar trial, right? So for each student I ask the same question and I get the 2 possible outcomes, pass or fail. Okay, so your experiment has to consist n number of identical trials. That's the very first characteristics. The second is that there are only 2 possible outcomes on each trial. Okay, so in each trial we always get the 2 possible outcomes, and we will denote one outcome by S for success. Okay, so every time if you have a binomial experiment, or if you have the experiment with the 2 possible outcomes, we denote one outcome by S, okay, for success, and other outcome by F for failure. For example, if I toss a coin, our outcome is head and tail, right? So we can call head as a success and tail as a failure. So make sure to denote your outcome by S and F. S is for success and F is for failure. You can call your getting head as a failure, it does not matter. Okay, and getting tail as a success. So you have the 2 experiment. Your experiment has a similar trials. Each trial has a 2 possible outcomes. Okay, one outcome is success, S, we use S to represent success, and another outcome is failure, we represent by F. The next characteristics is that the probability of S, so S is the success, okay, the probability of S remains the same from trial to trial. Okay, now, so let's go back to tossing a coin. Now if I toss a coin for 5 times, and let's denote getting head as a success, okay, and getting tail as a failure. So what would be the probability of getting success, which is head, in first trial? So getting success means getting head. So what is the probability of getting success in first trial? 50%. Now I'm into my second trial. Now what is the probability of getting success in the second trial?
25%.
It's the same, right? So so you have the first trial, the probability of getting head or probability of having success is 50%. Now we do the second trial. We toss the coin. It's the same experiment, okay? And your outcome is same, head, tail. The probability of getting head is 50%, right? So in the similar way, for each identical trial, the probability of the success it has to remain same, okay? So we denote the probability of success by P. So we use P to represent the probability of success. Okay, and we denote the probability of F by Q, and Q is always 1 minus P. So the probability of getting head is 1/2, right? To find the probability of getting tail, we find 1 minus 1/2, which is we still get the 1/2. So if you have P as a probability of success, 1 minus P is your Q, and Q is the probability of failure. Okay, so this is the third characteristics. The next one, the trials are independent. Okay, so here the trial has to be independent. It means the probability of getting success in first trial should not depend on second trial. Okay, all of those trial, like tossing a coin 5 times, they are independent of each other. Okay, so if you get head on your first trial, now does this getting head on the first trial affect the probability of getting head in the second trial? It does not affect, right? So it does not change the probability in the second trial. So our trial has to be independent. Okay, and being independent means the probability of getting the outcomes in the second experiment does not depend on our first experiment. And the last one, so we have X here. So X is the binomial random variable, and this X is always the number of success in n trials. So X is the binomial random variable, and it has to be always number of success in n trials. For example, if you define your getting head, getting tail as a success, okay, now if you define getting tail as a success, then X is the number of getting tail, or the number of tail. Okay, number of getting, or the number of tail. So it depends how you define your success, and your X is always the number of success in n trials. If you call your S as a observing head, then X is the number of head observed in the experiment. Okay, so it always depends. You can define in any way, but once you define your success and failure, make sure, just be careful when you define your binomial random variable. Okay, it has to be always the number of success in n trials. Okay, now here we have an example, and we need to decide whether X is a binomial random variable or not. The very first example is a university scholarship committee must select 2 students to receive a scholarship for the next academic year. Okay, so we have the scholarship committee, and they are selecting 2 students to receive a scholarship. The committee received 10 applications. Okay, so they have 10 applications for the scholarship, 10 from male, 4 from female students. Suppose the applicants are all equally qualified, so that the selection are randomly made. Let X be the number of female students who receive a scholarship. So we have a X defined as the number of female students who receive a scholarship. Now, is our X a binomial random variable or not? And to be a binomial random variable, okay, all of these 4 characteristics has to be satisfied. Okay, now, so we have the 10 application. Out of 10 application, 6 is from male and 4 are from female. Okay, now will our X, which is the number of female students who receive a scholarship, be a binomial random variable or not? Now, at first, do we have identical trials? Now, in this experiment, so what is the experiment here? Selecting 2 students to receive a scholarship. That is the experiment. Now, in this experiment, do we have identical trials? You have 10 students, okay? And out of 10, 6 are from male, 4 are from female. Now you are selecting 2 students. How do you select? So you are selecting randomly, okay? Yeah, that's what is said here. The applicants are equally qualified, okay, and the selections are made randomly. So you have 10 applicants, write each of their names, okay? Now you put those name on some bowl. Now if you like, how do you do your experiment? And you have to select 2 students. Sergio, you want to add something? Yes.
Yes, the answer no, because...
Okay, before we make a decision here, now do we have a identical trial or not? So you have 10 different students and you are picking 2. So how many trial will we have? How many experiment do we need to perform here? 2, right? So you just just write down your write 10 students' name and you just pick one by one randomly. So you pick 1. So that's your 1 trial. So you have 1 student. You pick another name. That will be your 2nd trial. Okay. Now here we do have a very similar experiment. Okay. So we do have a 2 identical trial. Now let's go to the number 2. So now there are 2 possible outcomes. Now, so our success is getting female, okay? So your success is getting female. So let's define our S to be success is getting female, okay? So like when you pick out of 10, if you get a female, that is your success, okay? Let's define it that way. And your F is getting male candidate, okay? So we define S as a getting female and F as a getting male. Now, so we define here, there is nothing more. Now let's go to number 3. Now, will be the probability of getting female be exactly same in the first trial as well as second trial? Now, let's find the probability of getting female in the first trial. So what will be the probability of getting female in the first trial?
6 over 4.
6 over 4.
6 over 10.
4 over 10.
Probability of getting female. So we have 4 female and the total number of application is 10. So 4 over 10 is the probability in our first trial. Now in the second trial, what will be the probability of getting female in the second trial?
If you got male in the first...
Yeah, you have to remove a name in the second trial.
So for example, in the first trial you got the female. You have the female. Now what is the probability of getting the another female in the second trial?
3 over 9.
Do you all agree it's 3 over 9? You already picked 1 as a female. So we have 3 female left and total 9 applicants, right? So 3 over 9. Now if you have like a male on your first trial, what will be the probability of female in the second trial?
4 over 9.
4 over 9. And what will be the probability of getting female in the first trial? If you have a male, okay, so when you select first time, you got the male. Now what is the probability of getting female in the first trial?
In the first and the second.
In the first. So you have a male. You picked 1, you already have a male. Now what is the probability of getting female in the first trial?
4.
It's 0, right? You already picked male. The probability is 0. So here what I'm trying to tell here is that in each trial we have like a different probability. Okay? The probability of having success or probability of getting female has to be same in each trial. But this is not true here. Okay? So 3 is not satisfied. Now what about number 4? Now are the trial independent? Now we have a 2 trial. They are not independent, right? The probability for the second trial depend on the first trial. So because of number 3 and 4, it does not, these 2 criteria are not met in this experiment. So our X is not a binomial random variable. Okay? So X is not. So here I'll just mention not here. So X is not a binomial random variable. Now let's go to number B. Before marketing a new product on a large scale, many companies conduct a consumer preference survey to determine whether the product is likely to be successful. Suppose a company develops a new diet soda, okay, so they develop a new diet soda and then conducts a test preference surveys in which 100 randomly chosen consumers state their preference from among the new soda and two leading sellers. Okay, so the company has develops a new soda, okay, and they want to get feedback from the consumers, and they have like 100 randomly chosen consumers. Now, if X is the number of 100 who choose new brand over the other two, is our X a binomial random variable? Now, so you have 100 consumers, okay, and each consumers they get they get the new diet soda, okay, and they are asked whether they prefer new soda or two different some leading sodas, okay, like for example, let's say Coke and Pepsi. Okay, you have a new brand soda, and each of 100 consumers are asked whether they like the new soda or Coke and Pepsi. Okay, now excuse me. Now in this experiment, how many trials do we have? So what do we do? So we have 100 consumers. Okay, for each consumers we give new soda and Pepsi and Coke. Okay, for all of these consumers, and we want to know their preference, whether they like the new soda or Coke, Pepsi. Now, how many trials we will have? 100, right? Now, are all those 100 trials similar?
Yes.
Okay. Now, how many outcomes do we get? How many outcomes do we get from this experiment?
100.
So you have a new. So in one trial, for example, I gave you new soda and Coke and Pepsi. Okay. Now, what are the response? How many response do I get from you?
One.
So you have the option to choose new soda or Coke and Pepsi. Coke and Pepsi is a. Let me take only one best seller, Coke. So you have a new soda and you have a Coke. Okay. Now you're gonna tell me which you like. Now how many responses do I get?
You can have two or
So you're gonna tell me one, but the possibility, yes, right. The possible outcome is always two, right? So you're gonna tell me new soda or Coke. So, oh yeah. Now, so we have 100 identical trial. Okay, so this experiment meets first characteristics. The second is there are two possible outcomes. Yes, new soda or the Coke or Pepsi. Okay. Okay, now how do we define our S? So our S, now here, X is the number of 100 who choose the new brand, right? So success is those who choose the new brand, the number of customer who choose new brand. So this is our success. Okay, if some of you tell me that you like new brand, then that is my success. Okay, so our S is the number of customer who choose new brand soda. And what will be F? What will be failure? Failure will be the number of customer who choose two other sodas. Okay, so we have two possible outcomes here. Now let's go to number 3. Now, will be the probability of choosing new soda for each of 100 customer be exactly same? So will be the probability that the customer choose new brand soda for all 100 customer will be exactly same. Now what is that okay, you said no. So what is the
I
okay?
feel like there's a predisposition of people.
So what is the probability of that you choose new soda?
You have to know what you have to taste.
So you have the two options.
What you
So you have the option of choosing new soda or Coke. What is the probability that you choose new soda? 50%, right? And Is that same for all 100 customer? So you have only two options, right? So the probability of choosing one new soda or Coke is same. So we have the probability of success same in each in 100 trials. Now, so similarly we can find the probability of failure. It will be 50%. Now, is the trial independent? Do you all agree? Are the trial independent? We have 100 trials. Now, are 100 trials independent? Okay. Now, yeah, so all four criteria it met. So our X, which is the number of 100 who choose new brand over the two others, is a binomial random variable. Okay, so this is yes.
So to determine, we have to go through all 5 steps and
Yes, you have to make sure that these 5 characteristics is met in order to make a decision whether your X is a binomial random variable or not. Okay. Now here,
like on our answer, then we have to include.
I mean, if it depends. Like if I mention you to just write the region, then you have to write. Okay. Or if you are simply asked to choose yes or no, then you just pick yes or no. Like it depends like how you have the question. Okay. Then last example here we have. Some surveys are conducted by using a method of sampling other than simple random sampling. Okay, for example, suppose a television cable company plans to conduct a survey to determine the fraction of households in a certain city that would use its new fiber optic service. So here the cable company want to know whether they will use their new fiber optic service or not. The sampling method is to choose a city block at a random and then survey every household on that block. Now here, so we have a cable company and they want to know whether the customer will use their new fiber optic service or not. So at first they choose a city. Okay, then in the city they choose a block. Okay, like in Portales we have a different residential area, right? So let's call each residential area as a one block. Okay, so they choose a block at random. Then they survey every household on that block. So at first they choose the residential area, and in the residential area we might have like a different number of households, right? Then they surveyed each household from that block. Okay. This sampling technique is this is the cluster sampling. Okay. So here, for example, we have this city here, and city has a different residential area. Okay, right? So here, so we have 4 residential area. Okay, the cable company they choose a block. For example, let's say they choose this block and this block. Okay, 2 residential area. Then each block, in each residential area, we have a different number of household. It may be equals, it may be less. Okay, so there is different number of households. So they surveyed each household. Suppose 10 blocks are sampled. So they sampled 10 blocks, producing 124 household responses. Okay, so they have 10 different residential area. They went to 10 different residential area, and they have 124 household responses. Let X be the number of 124 households that would use FIOS, which is the new fiber optic service. Now, is your X binomial random variable? Okay, Sergio said yes. Do we have any more S? So how many of you think X is the binomial random variable? Can you raise your hand? Sergio, Cooper, right? Okay, Cooper. Okay, and the remaining is no. Okay, let me start from Sergio. Okay, now what make you think that X is a binomial random variable?
Well, out of these 10 blocks, it's 124 people.
Uh-huh.
All they're doing is deciding if they want to use the new optic.
Mhm.
So the option says yes or no.
Yes, okay, so they are identical. They have a 2 response, yes or no, okay.
So I think the 10 blocks is just to divert your attention from.
Okay, that's okay. Arthur, you want to tell me why it is not a binomial random variable? What do you think? It's just a guess. I do have a reason for you.
Well, if you consider that like the 10 blocks
Uh-huh.
example, so I don't know, like in each of the blocks, is it independent? But like when you get them all together, they're not independent anymore.
Okay, now do it. Okay, okay, you want to add, Kayla?
So no, because probability is not the same for each, like sample that they take.
Okay,
The
so
number
let me
of
cut. Now
houses
he.
differs from each, like from each different time they go and take the same exact tests. The experimental values change every single time they retest
So why the probability is not same here?
because different amount of houses on different blocks.
Oh, just like for example.
Like if they were to do it again, they could and do another 10 blocks. The number of houses would be different, and so they would not get the same probability as the first time.
But you're gonna take the total number of houses is always 124. Arthur, you think you wanna add something?
Like, it's because the 124 household responses are like the people that answer or the people that use the FIOS.
So you have the 124 responses. You mean they answered?
So
Yes or no? The answer.
where's the ones that use the FIOS?
No. It's not that 124 want to use the FIOS. So they have the 124 answers. Okay, out of them, we don't know how many S's we have, how many no we have. But 124 they have the response. Okay.
So like once you separate them in 10 blocks.
So you at first you have that you choose 10 block randomly. Okay, like in a portal, let's suppose we have like a 50 blocks, and out of 50 blocks we choose 10 blocks randomly. So if we choose 10 blocks randomly, okay, so whenever we have the simple random sampling, then the probability remains the same. You choose the 10 blocks. Now once you choose the 10 blocks, you visit each 10 blocks and collect the response from every household in each block.
Yeah, they're independent, right?
Are they dependent? That's the measure here. Are they dependent or independent? Like for example, so I have like 5 students in one block, okay, and the remaining in the second block. Now, does the response of Kayla depend on the response of Imani?
No.
But they are in the same block. Okay, they are staying. They have their house very close to each other, very near to each other. Now, is there any chances that they're gonna have a common response?
Maybe, but like it depends because she can sign for FIOS, but if the first one doesn't want to, it doesn't affect as much.
We can have a common response based on like an economic background, but because low and high income neighborhoods are a thing, and so if you go to a low income neighborhood, they're probably gonna all answer about the same amount.
Okay, now how many of you agree to the Kayla her response? Can you just repeat that?
That depending on which blocks you go, there are like high and low income neighborhoods, and so the probability of like a high income neighborhood would probably be more than a low income neighborhood.
Yeah, but the thing is we don't have any information on the background or anything. Like as far as we know, they are completely exact. It's like just 10 random blocks of
Yeah.
a random city. So we don't know we don't know any background information. So as far as the exercise and the information that we have is literally 10 random blocks with random people living in, zero information. So they're
Now, how the blocks are how you have visited now, how the blocks are or the residential areas are created, as Kayla said, we have like a residential area for like a special like a residential area for the low income family or like a high income family. We have seen that, right? Like if we just visit, we see a different residential area, and the household in each residential area they have like very similar. Economical, they have very similar like income or even by education, since the education determines the income in one way. Okay, so there is a chance that the response of Kerala might depend on the response of Heidi.
Yeah, but like I think that
Sorry,
to
Imani.
consider that we have to have the information on the
That's right. But okay, now here, but if you can clarify, if you have region, yes. But in general, okay, like in general, I think it does depend. Like okay, for example, if this is very,
Is it binary or not? Is it binary or
now if it is dependent, then it is not a binary. It has to be independent.
Yeah, but like in this exercise,
Uh-huh.
like just with the information that we have here, is it dependent or not?
Now here, we should go with no.
Okay, so it's independent.
It's not. Yeah, it does depend. Okay, the
Just 'cause I was kind of confused because I was like, oh, in this exercise we don't have any background information, we don't have context. We don't
so
have-
it's gonna be like, but yeah, like you can have the region like you said, but if you mention that, you still get the credit.
Yeah,
Okay,
you have like
so
a
it
context
all
for it,
depends.
then
So it's not 100% that is no. You can also argue that it is yes. Okay, but it's gonna be a no. Okay, now here the main thing is that if you have a cluster sampling, then it is always no. Like here we have a cluster. See, so if the sampling method is cluster, it is always no. But if you have a simple random, like here like here in the example 2. So if we have the sampling simple random, it is yes. Okay, but if you have cluster sampling, then because we make a group that has a similar characteristics. Okay, so 10 block has a similar characteristics. So the responses may depend on each other. So if you see a cluster, always go with no. So let's do this much. Remaining we'll do our next.